Okay, you can see here uh, maximum mode configuration of 8086 microprocessor. Right. What maximum mode of 8086 microprocessor. Right. So how you can say that previously also we discussed that processor 8086 you can connect or you can use as a minimum using minimum mode configuration and maximum mode configuration, right? So this one is going to be decided by the pin number 33, right? So this pin number 33 here you is connected to ground. That is the region this processor now we are going to use in maximum mode configuration, right? So pin number 33 is connected to the ground. That is the region you can say that this is going to be work in maximum mode. Maximum mode means more than one processor is going to be come into the picture to use this particular peripherals through buses. Alright, so this is the maximum mode. So apart from this particular pin, these three pins you already know, this one reset, clock and ready pin. So these signals are going to be generated by the clock generator IC, right? From that we are going to get the ready, reset and clock signals to the processor, right? So apart from that, what we need to understand here is that as like 80 as like in minimum mode configuration, here also in maximum mode configuration also we need to use three buses, that is the address bus, right, data bus, and this is the data bus, right, and control bus and control bus. So address bus, data bus, control bus, right? So how many address lines are there? 20 data lines, 16-bit, and control signals. We are going to get these control signals. Anyway, you know that the major control signals are memory, read, right, control signal, memory, write, control signal, right, IO, write, uh, control signal, right, IO, read, control signal, right. So these are the control signals normally we need to generate to perform memory read write or IO read write operations. Data bus is used to transfer the data in bidirectional depending upon this control signal. This one address bus is used to select the particular chip, select the particular mm, particular chip, as well as to select the uh, memory location in that particular chip, right? Memory location in this particular chip or IO device or IO device, right? So this is the use of address bus, this is the use of data bus, this is the use of control bus, right? So this address is going to be generated by the address pins of the processor, and data transfer will takes place through data pins of the processor, and control bus is going to be generated from the control signals, right? So previously also in maximum in minimum mode configuration we have seen how the multiplexed address and data pins, as well as multiplexed address and status pins, right? These 20 pins, how it is going to be generating address bus by making ALEs high in the first clock period of the timing we discussed, right? So for that we are going to use this particular ALE signal to demultiplex from the multiplexed address and data bus, right? uh, and how we are going to be right? All this we discussed in the while discussing about 8086 minimum mode configuration. Right. So how it is generating multiplexed address and data while using ALE signal, right? Using ALE signal, how it is going to be generating address as well as data. Uh, that is you can observe here. Apart from that, here a major difference between the minimum mode and maximum mode configuration is that these control signals, how you are going to generate these control signals, that is the only difference between the minimum mode and maximum mode, right? So in minimum mode, whatever the control signals we are using, like in minimum mode, what control signals you use, these pins are there. Memory uh, uh, by IO bar, right? Read bar, write bar pins are there, right? In minimum mode configuration, using these three pins, we are going to be generate memory read, IO write control signals using DMux. But here these control pins are not there in minimum mode, right? We have a only status pins, right? Status pins, S0 bar, S0 bar, S1 bar, S2 bar, right? These status signals we have. So from this status pins only, we need to generate these all control signals. We need to generate all control signals. See, you can see here, these three pins are going to be connected to the 8288 bus controller. 8288 bus controller, right? So along with this particular clock signal, S1, S0, S1, S2, you are connected to the bus controller, right? So bus controller, based on the status of these three inputs, it is going to be activate one among the these output control signals, right? So bus controller is responsible to generate memory read, IO write, interrupt acknowledgement, data transmitted by receiver bar, right? Data enable, ALE signal, ALE signal. See, these all control signals are going to be generating from the bus controller by taking this particular status input, right? Based on the bit combination of these status signals coming out from the 8086 in maximum mode configuration, it is going to be generate one control signal, right? It is going to be activate any control signal based on this particular status. Once this status is changed, output is also going to be changed. That's obviously, right? This whatever the function processor want to perform, based on that it is going to be out some status signals along these three pins, right? That three pin status signals is going to be act like a input to the bus controller. Based on that, this output is going to be activated, right? These outputs are going to be connected to this particular peripherals, right? Here also same thing, you can see remaining all diagram is same in as like in the minimum mode configuration, as like in minimum mode configuration. See here, RAM is there, ROM is there, and IO module is there. IO module is there. IO module is there, right? So you all know that this ROM is used to store the operating system, RAM is used to store user program as well as data, as well as, right? Here is what these peripherals are there. So RAM is used to store the user program as well as user data. IO device are used to give input data as well as to out the data, right? So to communicate with any peripheral which is going to be interfaced to the 8086 in a maximum mode. So previously also we discussed that if we want to communicate any device, what we have to do first is we need to select the particular device, right? Once it is selected, right, you then once you select that particular chip select, then location in that particular location in that particular chip. For example, you select memory chip, right? Then you need to select the one register among the particular memory chip. If you select IO device, we need to select the one device, one IO device among the n IO device, right? And then we need to send the control signal. What operation has to perform on that particular control operation, or you can say that control signal, right? Why? Because Once it is selected, you want to read or write the data from the particular chip. That means particular location. Then data transfers we need to perform. Transfers we need to perform. We need to perform means processor need to be performed. First, what we have to do, processor has to do first. Processor has to do select the chip as well as select the location. For that, it is going to use address bus, right? For that, it is going to use address bus. How many address lines are there? 20 address lines. So 20 address lines. It has to use. It has to use. Uh, this cursor is not moving properly. Right. So this address multiplexed address and data bus has to use first to select the chip as well as to locate the particular location in the particular chip. Right. See here, all 20 are going to be connected to the 3 latches. Previously also we discussed this particular one. 8 pins, each 8 pins is connected to the one latch, and another 4 pins are connected to the last latch, right? It is going to get the signal, ALE signal from here as an input, right? So it is going to send out some status to produce the ALE signal until the first T state, right? Then this way is not going to be used. This is the way input is going to be act. Then you are going to get the 20 address, 20 pins address, 20 bit address from the 20 pins of this particular 3 latches, right? That is going to be used to select the particular chip as well as particular location in the particular chip, right? For example, this is the chip is selected, right? Chip select even RAM is going to be selected, for example, based on the higher bit, higher pins of the address as well as bus I enable and A0. Bus I enable and A0. Previously also we discussed in the same way for the minimum mode configuration also, right? Higher address lines as well as A0 and BH E bar is going to be act like input to the chip select logic that is used to select the one chip among this particular 4, right? Even RAM or odd RAM or even ROM or odd RAM or IO is going to be selected. Once it is selected, lower address lines are going to be used to select the particular location in this particular chip, right? So this location, once it is selected, then it needs to provide the memory read or write control signal, right? So as well as it has to make ALE 0. Once ALE is 0, this way is going to be closed. Now this way is used to transfer the data through bidirectional buffer depending upon the control signal, right? Depending upon these two control signals, memory read or write, something is going to be, one among the two signals are going to be activated based on that particular signal, right? Data is going to be read into this location or write into this location or read this location data to the processor through this particular bidirectional buffer, that is data buffers. Data buffer is going to get the other two control signals, that is data transmitting or receiving, data enabled or not, right? If it is one, data enable is 1, that is data is available on the data bus. Data transmitted by receiver bar is 0, right? It is receiving the data, right? If it is read control signal, this is going to 0, write control signal, this is going to be 1, right? So like that, its data transfers will take place. Right? So the three control signal, see here, right? For address bus is going to be used along with ALE signal, right, to select the chip, as well as to select the location in that particular chip, right? Control signals is going to be based on the status. This control signal is going to be activated. That control signal is going to act like a input to this particular chip. Then data transfers will take place through data bus. By the time ALE is going to 0, that is the region this way 16 pins. So two bidirectional buffers are connected. So 16-bit data is going to be transferred. This is where communication is going to be takes place. Control bus is going to be used, data bus is going to be used. So this is the maximum mode configuration, and this is the way this communication will takes place between the peripheral and processor in maximum mode configuration. So major difference between the minimum and maximum mode is the how it is going to be generating the control signals, right? So previously control signals are going to be generated like this by using these three pins, by using the external this one DMUX is going to be generating the control signals. Here is what the control signals are going to be generated based on the status in out from the processor, right? So this is the bus controller, the extra thing is come to the picture, and maximum mode configuration to generate the control signal. This is the one thing is difference between the maximum and minimum mode configuration along with this particular connection, 33 pin connection, right. Thank you. This is about the maximum mode configuration, right.